Hey guys, hope you enjoyed trying our second daily challenge. This one's a little bit harder than the first one, I think, mainly because of the algebra that's involved. So it was quite easy to get lost in the algebra here, but the trigonometry that we need is pretty basic still. So the key here is that we have these two right angle triangles, and so sort of the only thing that we can really use here is Pythagoras' theorem. We're going to add in these two variables. So we've got A and B, right? Because we'd really like to use the two right-angled triangles rather than the larger triangle. All right. So there's a few ways that we can link all these variables together. So the first way is to use this common edge, right? So if we apply Pythagoras' theorem to the left-hand triangle, we have that sort of 12 squared is equal to x plus 2 squared minus a squared. And if we use the right hand triangle, we get that 12 squared has to be equal to x squared minus b squared. So since both of these expressions are equal to 12 squared, it must be the case that they're equal to each other, right? So we now have x plus 2 squared minus a squared has to be equal to this thing, x squared minus b squared. And now we're going to shuffle some things around, so we'll move the a squared over, and we'll move the x squared to this side. So we're going to have x plus 2 squared minus x squared is equal to a squared minus b squared. And this is a really nice setup for a difference of two squares on both sides, right? So we have a square minus another square, so we can factorize that as the first thing minus the second thing times the first thing plus the second thing. And we can do the same thing on the other side. So we get a minus b times a plus b. Okay, and then the reason this is helpful is because we know that a plus b is actually x plus 1. And so on this side, this simplifies down to give us just 2 in this bracket times this is now 2x plus 2. And that is going to be equal to a minus b times a plus b, which is really x plus 1. Alright, so we'll bring that up here. So now we can actually factor out a 2 in this side. And this allows us to then cancel the x plus 1s on both sides, because we know that x is not negative 1, right? This thing can't be 0. That's not equal to 0, so we can divide both sides by that. And we're going to end up with 4 equaling a minus b. Alright, so we can now use this extra bit of information to get b in terms of x. Right? So if we take these two equations and subtract this first one from the second one, we're going to get x plus 1 minus 4 is equal to 2b. Okay, which tells us that x minus 3 is equal to 2b, and so b must be x minus 3 over 2. Alright, so now that we have b in terms of x, we can now just use Pythagoras' theorem on the right hand triangle, and that'll give us a quadratic equation for x. Right, so we now have 12 squared plus b squared equals x squared, and we know that b is really this thing. And so we can then just expand this part out, right? And then if we multiply everything through by 4, we'll get rid of this annoying fraction. So now all that's really left to do is solve this quadratic equation. So we're just going to expand first. And simplify some of this. So we want to get everything over to one side. So we're going to move all this stuff over to the right hand side. And we end up with this. Okay, and it turns out that these all have a common factor of 3, so we can divide that out. And then luckily this factors nicely. And so either x is minus 15 or x is 13. And so obviously x can't be negative, so this is our only solution, that x should be 13, and so our side lengths are then 13, 14 and 15.